This is a sample of the information provided as part of the flexible training resources available through HACCP.com. Our training courses are designed to provide training participants with an understanding of food safety and quality system elements and also offer user-friendly assessment activities and competency checklists to complete the training cycle. Key definitions for air and gas standards. Aerosol. An aerosol is a substance enclosed under pressure and released as a fine spray by means of a propellant air or gas. In the context of air and gas standards management, this may include water and chemicals propelled into the air or onto product or product contact surfaces. Microorganisms may potentially be transported by aerosols onto product or product contact surfaces. Anemometer. An anemometer is an instrument for measuring the speed of the wind, or of any current of gas. HEPA, high-efficiency particulate air or HEPA, also referred to as high-efficiency particulate absorber, high-efficiency particulate arresting or high-efficiency particulate arrestance, is a type of air filter. Filters meeting the HEPA standard have many applications within the food sector, including direct and indirect applications. Positive pressure air system. Positive pressure is a pressure within a system that is greater than the environment that surrounds that system. Consequently, if there is any leak from the positively pressured system, it will ingress into the surrounding environment. Ventilation. The provision of sufficient airflow to facilitate required tasks. Air and gas standards development. When considering the development, documentation and implementation of air and gas standards within food safety and quality management systems, the following information should be considered to ensure effective outcomes about air and gas management. Environmental air quality and ventilation. Microorganisms of concern in air and gas management. Monitoring and verification of air and gas. About air and gas standards. Air and gas standards must be risk assessed, controlled and monitored on an ongoing basis to ensure appropriate outcomes are maintained. HACCP risk assessments are commonly used to identify specific potential hazards that may result from a lack of control in air and gas standards. Environmental air quality and ventilation. Adequate means of natural or mechanical ventilation should be provided within food processing and packaging areas to minimize airborne contamination of food from aerosols and condensation droplets. Control ambient temperatures. Control odors which might affect the suitability of food. And control humidity, where necessary to ensure the safety of food. Ventilation systems for high-risk or high-care foods should be designed and constructed so that air does not flow from contaminated areas to clean areas and, where necessary, they can be adequately maintained and cleaned. Condensation caused as a result of poor ventilation can facilitate cross-contamination by transporting microorganisms into foods. The problem can be controlled through ensuring adequate airflow around food products, evaluating ventilation systems, and controlling temperatures in processing, packing and storage areas. The air and gases used in food production, packaging or within the food premises, regardless of whether considered as an ingredient or not, should be monitored regularly to ensure they do not present any food safety or quality risks. It is important to prioritize the scheduled testing of air and gas sources to ensure they are not impacting upon the safety or quality of the foods being produced. Microorganisms of concern in air and gas management. The microorganisms of concern in relation to air and gas management are many and varied and differ from site to site based on their site and the processes and products facilitated. Both pathogens and spoilage organisms may be nominated as microorganisms of concern. In conjunction with the risk of microorganisms being directly present within air flows or gas flows, the additional presence of fine moisture particles within such air or gas flows may exponentially increase the risk of microbiological contamination. Documented HACCP plans and their risk assessments should be used to identify and manage related risk at the process steps where contamination may occur from air or gas flows. Identification of air and gas utilities. As with other site utilities such as potable hot and cold water, wastewater and effluent, site air and gas utilities must be adequately identified to ensure they don't become a source of contamination. General best practices for all air and gas lines and systems to be clearly identified as their intended scope and purpose of usage, both physically within the site and within site plans and schematics. Related delivery points, filtration points and treatments should also be clearly defined. Where new or amended air and gas fixtures or fittings are applied, these should be reviewed and verified as part of commissioning and validation processes to ensure they don't introduce risk to related products or processes. About environmental air filtration. Environmental air filtration is an important factor in the management of airborne microorganisms and other contaminants that may enter foods from the available environmental air. Where environmental air filtration is required, the related systems should be selected and implemented in alignment with the outcomes of HACCP risk assessments. Air management systems for high-risk and high-care food production areas should be implemented and verified on an ongoing basis to ensure the ingress of unfiltered air into the high-risk area is minimized. HEPA filtration of environmental air. High-efficiency particulate air or HEPA, also referred to as high-efficiency particulate absorber, high-efficiency particulate arresting or high-efficiency particulate arrestants, is a type of air filter. Filters meeting the HEPA standard have many applications within the food sector, including direct and indirect applications. Where HEPA filtration of environmental air is facilitated within a food site, the sizing and operational efficiency ratings of related filtration units must be selected based on considered operational parameters. Filter management must be scheduled and managed as part of preventative maintenance routines commensurate with the risk status of related HEPA applications. This is regardless of whether related HEPA filtration is applied for direct or indirect applications. Monitoring and verifying environmental air standards. Standards for the monitoring and verification of environmental air standards rely heavily on the risk status of the relevant food site and the products/processes facilitated. For the most effective management of environmental air standards, the outcomes of any monitoring and verification activities should be ratified in conjunction with a strong understanding of applicable air filtration and air delivery systems. Common environmental air monitoring and verification activities include microbiological testing of collected air from microorganisms such as Listeria species, yeasts or molds. Microbiological swabbing of environmental air contact surfaces such as vents, ducting or filters. As with any targeted microbiological verification activity, the testing and assessment of air should be based on a logical risk-based methodology to ensure sampling points and methods and microbiological testing methods provide outcomes which genuinely allow for the ratification of risk. About positive environmental air pressure. Where positive environmental air pressure is facilitated within a food site, a significant volume of considerations needs to be processed to ensure the best outcomes. These considerations may include the volumetric size of the area requiring positive environmental air pressure and related capacity of the air production and air filtration systems. The ability of air production and air filtration systems to facilitate required capacity at different air temperatures, including during different weather conditions. The ability of air production and air filtration systems to facilitate required capacity at specified humidity levels, including during different weather conditions. The frequency of filter changes and how different filter loadings may impact upon the operational capacity and efficiency of positive environmental air pressure systems. The direction of positive environmental air pressure airflow within specified site areas, as this may impact upon the transport of particulates such as dust or aerosols containing microorganisms. Positive pressure airflow systems should be considered for high-risk and high-care areas to control the intake of airborne microorganisms which may potentially contaminate foods. Air being provided into high-risk or high-care areas, particularly for ready-to-eat products, should also be filtered to decrease the content and viability of airborne microorganisms which may contaminate foods. Within high-risk and high-care scenarios, air introduction and reticulation systems should be filtered to an appropriate standard based on risk assessment outcomes. Related positive pressure air systems should be implemented and verified on an ongoing basis to ensure the ingress of unfiltered air into controlled areas is minimized. Monitoring and verifying positive environmental air pressure. Standards for the monitoring and verification of positive environmental air pressure rely heavily on the risk status of the relevant food site and the products/processes facilitated. For the most effective management of positive environmental air pressure standards, the outcomes of any monitoring and verification activities should be ratified in conjunction with a strong understanding of applicable air filtration and air delivery systems. Common environmental air pressure monitoring and verification activities include verification of air movements through and out of a specific area using an air measurement device such as an anemometer. Microbiological testing of collected air from microorganisms such as Listeria species, yeasts or molds. Microbiological swabbing of environmental air contact surfaces such as vents, ducting or filters. As with any targeted microbiological verification activity, the testing and assessment of air should be based on a logical risk-based methodology to ensure sampling points and methods, and microbiological testing methods provide outcomes which genuinely allow for the ratification of risk. About compressed air. Where compressed air is used for product or product contact surface applications, it needs to be managed to ensure it does not introduce any food safety hazards. General requirements include the use of suitable compressed air sources for any applications where product or product contact surface contacts are relevant. Where compressed air is used within sealed systems which don't facilitate product or product contact surface contacts, safety and suitability parameters should still be risk assessed and considered for monitoring and verification activities where peripheral risks may be present. Filtration of product contact or product surface contact compressed air. Best practice food industry usage of product contact or product surface contact compressed air requires consideration and application of filtration systems to ensure moisture, chemical, physical and microbiological contaminants don't impact upon the safety or suitability of foodstuffs produced. The types of filters implemented should be based upon product risk status and the related processing methods applied. Did you know that HACCP.com includes resources that allow you to create, manage and implement GFSI and HACCP-based food safety and quality programs? Improve your food safety and quality skills and knowledge? Train and develop your team to create better food safety and quality outcomes? Find suppliers and service providers to partner with your business? The information and training resources available through HACCP.com included a variety of formats, such as website content, MP4, MP4 and text, MP3, PDF and slideshow. Are you ready to take the next step in your food compliance journey? Visit HACCP.com today to create your profile and access the full versions of our food safety and quality information packages and much more.